Okay, number 10. So the resistance of this is going to be a little tricky to do. What I'm going to end up doing is breaking down the circuit into equivalent sets of the circuit, if that makes sense. For example, what I want to do first is I notice that any current that comes out of the battery is going to have to go through R1. It gets here, it splits, and it rejoins here and goes through R5 and then back to the battery. It tells me that Rs 1 and 5 are in series with everything. So I'm going to save dealing with them for last. What I'm concerned about is this intersection here and how everything splits. I can go to the left to R2, or if I can go to the right. Now if I go to the right, I have to go through 3 and 4. I don't have a choice. So 3 and 4 are effectively one resistor as far as the entire circuit's concerned. Since they're in series with each other, it'll just be 10 plus 30, or sorry, 10 plus 20 equals 30 ohms. R1 would still be 3 ohms, R2 would still be 15 ohms, and R5 would still be 7 ohms. Now I'm going to simplify the circuit even more. I'm going to get rid of the entire parallel branch. So I have R1, Rs2, 3, and 4, R5. So R1, Rs2, 3, and 4, and R5. So the way that I go from having this to just one resistor is to use the parallel trick. So 1 over R for the parallel is 1 over R2 plus 1 over the R3-4 combination. So this is the left side and this is the right side. So 1 over R is 1 over 15 plus 1 over 30. That gives me 3 over 30. If I flip 3 over 30, that equivalence would be 30 over 3, or 10. So this here is 10 ohms. This is still 3, and this is still 7. And now they're in series. Current goes to the battery, goes through R1, goes to the 2, 3, 4 combination, goes through 5, comes back to the battery. 3, 10, and 7 is 20. So my total resistance is 20 ohms. At this point, again, pause the video if you want to take a look at the resistance notes. Let's move on to this column here. I have 2 in the column. So V equals IR, 120 equals I times 20. So the current would be 6. And 120 times 6 is 720. So the total power created by the battery is 720. Once again, 6 amps leave the battery. Those 6 amps have no choice but to go through R1. Then they get to the split. And then they rejoin here, have no choice but to go through R5 and back to the battery. So Rs 1 and 5 will be 6 ohms. That means R1, 6 times 3 consumes 18 volts. And 18 times 6 is 108 watts. Now 6 times 7 is 42 volts. And 42 volts times 6 amps is 252 watts. Sorry, I put this one in orange, 108. Okay. So, what I can say thus far is this line right here leaving the battery is 120 volts. R1 consumes 18 volts. And that means that R1 brings this line down to 102 volts. Working from the other end, this line here is at 0 volts. R5 consumed 42 volts, which means that this line has to have been 42 volts. What this tells me is R2 had to have brought the voltage from 102 down to 42, which means R2 consumes 60. R3 and 4 combined drop 60 as well, but I'm not quite sure how exactly it does that. We'll get to that one in a moment. I have 2 in a column. 60 equals 4 times 15. And 60 times 4 is 240 watts. Alright, our last bit now is, what about R's 2 and 3? And this is where we're going to bounce back and focus on the current and what the current does at the split. 6 amps went into this intersection, 4 went left. So how many went right? Well, 6 in, 4 left, that means 2 went to the right. 2 times 10 is 20, 2 times 20 is 40. So R3 consumes 20, R4 consumes 40, 20 and 40 is indeed 60. Power, 20 times 2 is 40, 40 times 2 is 80. Check to make sure that everything is correct. 108 plus 240 plus 40 plus 80 plus 252 is 720 watts. 720 watts consumed, 720 watts generated. This is done. Smiley face.